Hello, my name is Charles Wade. I'm a PhD student at the University of Colorado Boulder. Today I'm going to be picking up on my series of how to use OpenVCAD to design different objects. So today we're going to look at some examples of using meshes designed in other programs, importing them into OpenVCAD, and creating designs with them. So to get started, we'll look at a sort of very basic and traditional 3D printing example. This is a 3D Benchy that I downloaded online. I imported it. As you can see, one of the key things to understand first about meshes is going to be how we sample their resolution in, right? It's going to be dependent on how many voxels we're actually sampling up here, right? So let's say we make this number much, much bigger, right? So let's say we make this like 0.4 millimeters. Go ahead and render this. You can see our mesh got a little bit worse. You can change this again to make it even bigger. You can see we really start to lose fidelity on it, right? It's looking a lot more pixelated or voxelized now. Likewise, we can make this quite a bit smaller. Go ahead and render it. And it looks a lot nicer. So that's the first thing I want you to keep in mind when using meshes in OpenVCAD, is that they're going to depend on really two things: this voxel sample resolution, as well as the fidelity of the STL mesh you export, right? So like with most things 3D printing, you'll want to export your triangulated mesh with the highest resolution possible for applications that require a lot of dimensional accuracy. So let's go ahead and look at another example, right? So let's look at the OpenVCAD text here. Go ahead and render this. It'll render very quickly because we've got a pretty big voxel resolution. You can see we have this OpenVCAD text. Let's go ahead and make this a little bit higher resolution, right? So we'll render. Well, actually, we can do probably more than that. Okay, there we go. So looking at this text, you can see we've imported this as a mesh here. And then we've gone ahead and rotated it 180 degrees. This is because it was drawn in Fusion 360 about a different axis. And then I go ahead and apply a functional grade on top of that. So here I'm doing a pretty straightforward gradient effect. I'm defining 0.12 or 12% red, and then I defined this functional grade right here across the z-axis, sort of kind of in the center. And what that actually is doing, even if these things don't sum exactly to 1 to form a volume fraction, although that's what I recommend you do, in this case you can do things like this, where it will be normalized to 1, no matter what the sum of this actually ends up being. So let's look at something a little bit more complicated than that. Let's see how we can actually combine our meshes with other types of geometry and functions in OpenVCAD. So I'm going to go ahead and render this. Let's turn this up to a custom resolution. I'll let this generate the ray trace preview. Since we're working with sort of gyroid or lattice structures in this case, it's going to take a little while to load because we need a really high resolution to visualize it well. But what's happening here, kind of moving from the inside out, right, is we've done that same thing. We've imported our mesh, right, rotated it 180 degrees so that it's facing our camera, and making sure it's along the sort of x-axis. And then what we're doing is applying this function, right? We're going to take the intersection of this text and this function. And what this function is right here, this combination of sine and cosine, is actually the famous gyroid pattern. So by doing that, now that we've rendered, we can zoom in, we can really see that gyroid pattern, right? So that's combining our geometry, right? We have an external sort of bounding surface in the OpenVCAD text. We used this function to define internal geometry, took the intersection of both of them, and then finally we apply that same functional gradient on top of that. This time I rendered it at a higher resolution so we can really see it take that effect better, and we can see how that actually forms this gyroid. So you can imagine doing this with different lattice structures or gyroid patterns where you need to fill a volume. If we want to, we can actually kind of turn the transparency back on this, turn off the blue and come in and see the densely packed kind of red voxels in here. This is a much higher resolution than the last one I showed you, much closer to what you would expect to see a final object to look like. Right, so the preview in OpenVCAD depends a lot on how long you're willing to wait for getting visualizations that are pretty high fidelity and will look much more like whatever your final product is. One other thing we can do is sort of animate this. If I pause it, and seek back and forth, we can kind of see that the gyroid pattern, rotating in there. Let's zoom in a little bit more and see if we can get a better view. Yeah, so as I step through this, you can see that gyroid pattern rotating around and building that structure up. And as we take cross-sectional slices through this, we can see these blue pixels or voxels are getting intermixed with these red voxels, 100% through the object. What else can we do? What other combination of things can we do? Well, we can do things like okay, so what else can we do? Well, we can do other things like this multi-material gear I've defined here, right? So I've imported a gear STL, and then I'm applying a functional gradient as a function of a rho, right? So this is in cylindrical coordinates. So as rho increases, or as we move out along the gear, move out along the cylinder, the probability uses a sort of an exponential crossfade or a sigmoid crossfade to mix between red and blue. If I change this to threshold mode and visualize this, we can see exactly where that switch off point was, right? So this is where there's now more red than there is blue composition-wise. This is a good way to kind of debug and see where exactly your material transitions are happening. Another example we can look at is this graded wing. So I'll go ahead and render this. You can see I rendered it just with the default settings. It's kind of hard to see. We clearly don't have enough resolution. So down here in the render preview, I'm going to set it. It was already at high. Ultra would improve that, but I can set it to custom. And what custom is going to do is actually going to look at this voxel value up here and take that, right? So the ray trace preview will sample a different voxel resolution than what you provide here. Sometimes if you select something other than custom, just for visualization fidelity purposes. But if we set it to custom, run the ray tracing preview, we're going to get a much better preview of this object. This is one of the objects from the paper. It's a really interesting example because we're doing two things here. We're defining our mesh and we're defining a gyroid function just like we did before, and then combining them with an intersection. But one of the interesting things we're doing on top of that is notice how we have an x parameter in this gyroid function, in addition to the normal x, y, and z components that form the gyroid. So having this extra x term is actually allowing us to functionally grade the unit cell length as we move out along the wing, right? So you can see that, right? These unit cells are much, much bigger in the gyroid out here than they are out here in the wing. And that's intentional, right? As we move out, we need to preserve the geometric detail of the wing as we get out to the tip, something that we really don't need to do down here. We don't need gyroids with quite that small of unit cell sizes against the plane because we have pretty big sparsity out here. And then the other thing we're doing on top of that is using a function to actually functionally grade the red and the blue material as a parameter of x. So in this case, it's just a basic linear gradient effect.